Okay, hi everyone. Welcome again to Math 030. So let's discuss about the dot product. So what is a dot product? A dot product is just an operation between two vectors that results into a scalar value, wherein the operation is just an entry-wise multiplication and then finding the sum of its entry-wise multiplication. So basically, if we have, let's say, vectors A and B, so this is, let's say, vector A, with entries A1, A2, and A3 corresponding to its X and Y and Z coordinates of its terminal points. And then let's say we have B here, the same thing. If you want to find the dot product of A dot B, okay, so guys, don't be confused, no? This A here is the same as the A here. So we could notate our vector as a boldface, no? So this thick letter, or we can use the arrowhead above, no, as an accent. So this is the same thing, just in different forms. So again, the dot product of A and B, that is equal to the entry-wise multiplication. So we have A1 times B1, A2, B2, okay, and so on. So let's say we have two given vectors. How do we find its dot product? So for number one here, we have 2 times 3. That will be equal to 6, no? And then we have 4 times -1. So this will be just plus -4, or we just write here -4. So this will be 6 minus 4. That will be equal to 2. Okay, for the other one, we have -1 times 6. So this will be -6. And then 7 times 2. This will be 14. And then 4 times -1/2. That is -2. So this will be equal to -8 plus 14. This will be positive 6. And then for the other one, we have a different notation, but basically it is just the same thing. So how do we do this? Now, so be careful with your dot product. With this second vector, we do not have an I. No? So if we do not have an I, basically your coefficient here, or the length of your I, is 0. So we have 0I plus 2J minus K. Okay? So we have 0I if we do not have an I with this vector. So therefore, the dot product here, we have 1 times 0. Okay, so this will be 0 plus, we have -2 times 2. Okay, and then we have plus -3 times -1. So this will be equal to, so this is 0. So -4 plus 3. Therefore, their dot product will be -1. Okay, so that will be all for the example. So what can we do with this dot product? So the dot product has its innate properties, or its theorems. Now we call this the theorems that relates some of the different forms of the dot product. So if let's say we have a dot product of our same vector, no? So if we have a dot product of A with A, this will be the same as finding the length of A, okay, and then squaring its length. Okay, again, what is this? What does this mean? If we have two vertical bars, it means we are trying to find the length of A. The norm of A, the magnitude of A, they are the same thing. Okay, and then for the next one, we can see that the dot product is commutative. So A dot B is also the same as B dot A. And then we have the distributive property, we have the zero property, okay, and then we have still the distributive property, but with scalar, no? So assuming here that C here is a scalar, no, it's not a vector, then we can also, there is a commutative property of this dot product. Now, as you can see here, no, just to be familiar with the notations, if it is in boldface, it is a vector. If it is not a boldface, no, it is not in it's boldface, no, then it is a scalar or a number, no? So what can we do with the dot product, guys? So knowing that we have vector A and B, okay, we can actually have a relationship of this A and B, its angle in between this A and B, and their difference, you know? So graphically, we did not discuss this specifically, no, 100%. No, we did not emphasize this, but The subtraction of two vectors is actually just when you plot this first vector and the second vector with the same origin or its same starting point, and then connecting these two vectors, you will have the difference between these two vectors. And then seeing this, no, we can form a triangle that could help us relate their lengths. So to relate their lengths here, we could actually utilize a concept in trigonometry, which is the cosine law. So using the cosine law, okay, if you can remember, using the cosine law, you can find the length of a minus b. So the length of a minus b, okay, so this vertical bar means the length. So the length of a minus b is equal to the length of the a squared, the length of the b squared, and then minus 2 times the length of a, the length of b, and then cosine theta, right? So we know using the property, no, as we discussed the previous slide, this is also the same as, this is also the same as saying that we have a minus b dot product of a minus b. So therefore, we can rewrite this one using the distributive, no? There is a distributive property of dot products. We can say that this is a squared. Okay, so using the FOIL method, we have a squared, or sorry, not a squared, but a dot a. And then we have negative, so first, and then outer, we have a, and then negative b, plus we have inner, so we have negative b dot a, and then the last we have plus negative b dot negative b. If we simplify this, we can say, you know, that this is also, no, actually we could simplify this into the length of a squared, and then this one are like terms, and we know that the products are commutative, so we can rewrite this as negative 2a b, right? And then this one can also be rewritten, okay? This will become positive now, so we can just remove the positive sign. And then also now the same thing with what we did for the first term. This is also the length of the b vector squared. So we can rewrite this one, no, to the left side of this equation. So we can replace this one with this one. So this will be the length of a squared and then minus 2ab plus the length of b squared is equal to this. So we have a length of a squared plus length of b squared minus 2 times the length of a, length of b, cosine theta. So as we can see here, we can cancel out this a squared and also this b squared, no? So what do we left here? What do we have left here? We have 2ab is equal to 2, negative 2, the length of a, the length of b, cosine theta, no? So we can cancel out this negative 2, okay? So we have left here is, actually this is a dot product, I forgot to notate this as a dot product. Sorry guys. This is a dot product, so this should be a dot product. No? So the dot product of a and b is equal to the length of a times the length of b cosine theta. Therefore, we could say, we could have this new relationship of the dot product of a and b is equal to the length of a times the length of b times cosine theta. We can also find the angle theta using this relationship now. So we could rewrite this equation as cosine theta is equal to a dot b over the length of a and the length of b. Or, no, to find theta, this is just the inverse cosine. No? Inverse cosine, we have a dot b over the length of a, the length of b. So this will be your other equation. All right, so that will be another definition of the dot product a and b. This is equal to the length of a times the length of b times cosine theta. So there's a relationship of this angle and lengths of AB with this operation, this dot product. Now, let's say we have a problem here. If we have two given vectors A and B that have the length of 4 and 6, and the angle between them is 60 degrees. So find the dot product A and B. So again, we have a given here an angle and we have the given lengths. So basically this angle is theta and this are the angle of A and B respectively. Okay. So therefore, we know that the relationship of this vector A and vector B is equal to the length of A times the length of B cosine theta, and we have this all given, okay, then therefore this is equal to, so we have to notate this as a arrow, no? So this will be 4 times 6, okay, cosine 60 degrees. Now this will be equal to 24. Now, how do we evaluate cosine 60 without using calculators? So using the special triangle, okay, we have the special triangle with an angle. I think we have to make things much more scaled, in a much scaled manner. So we have 60 degrees, 30 degrees. So we have 2 as our hypotenuse, and then we have 1, and then we have here square root of 3. Therefore, we know that cosine 60 degrees is equal to, so the cosine 60 is thus the adjacent over the hypotenuse. So therefore, this is equal to 1/2. Therefore, the answer here, we have to multiply this by, so cosine 60 is equal to 1/2. So the answer here will be 12. Okay? It's that easy. Okay? Okay, another example here. So find the cosine theta between the vectors A and B. Okay, so how do we do this? We have the, the two vectors given. We want to find the cosine theta. So again, we have the vectors A dot B is equal to the length of A, length of B, cosine theta. So to find cosine theta, we have A dot B, and then over the length of A, length of B. So how do we find the dot product? It is fairly simple. We just do the entry-wise multiplication. So we have 5 times 2, that will be 10. We have negative 3 and 2, so plus negative 6, so minus 6. 2 and negative 1, so minus 2. So this is our numerator. Now for the denominator, how do we find the length? So we know, guys, that the length of our vector, let's say vector A, this is the square root of the sum of the squares of their components. So we have a1 squared plus a2 squared plus a3 squared. So therefore, the length of A is just the square root, ano? The square root of 2 squared plus 2 squared plus negative 1 squared. And then plus, sorry, not plus, but multiplied by B. So B here. So square of the sum of the, so square root of the sum of the squares. So 5 squared plus negative 3 squared plus 2 squared. Again. Okay, simplify this. So we have 10 minus 6 minus 2. So this will be just 2, right? And then all over, so what is this? So we have 4 plus 4 plus 1. So this is the square root of 9, right? And then for this one, we have 25 plus 9, and then plus 4. So that will be equal to 34, and then times plus 4, no? So this will be 38. So we have square root of 9 times square root of 38. Okay, we can evaluate this one. So this is equal to 2. The square root of 9 is equal to 3. So 2 over 3 square root of 38 is the answer. So you do not need to use your calculator. This will be your answer for the cosine theta only. So if you want to find the angle, you can use your calculator. Just use inverse cosine, no, of 2 over square over 3 square root of 38. That will be equal to theta. So it is up to you to figure out if you want to do this, or if you want to have some how do you call this numerical value of the representation of the angle theta. Okay, so let's talk about the orthogonality of a vector. So if two vectors A and B are orthogonal, then their dot products is equal to 0. So why is that? No? So if you could recall again, theta, or sorry, cosine theta is equal to A dot B over the length of A times the length of B. So if this becomes 0, no? So let's say this becomes 0, then this will be 0 over this length, no? This multiplication of these two lengths. So basically, this is just 0. So when is the angle, no? What is the angle theta when this will become 0, no? So the angle that makes this 0 actually is 90. So if theta is equal to 90, or in other words, cosine 90 degrees, this will be equal to 0. So therefore, what does orthogonal mean? Orthogonal, in other words, in simple terms, it basically means it is perpendicular. So just remember this definition because we will utilize this until the very end of this course. Ano? So show that these two vectors is perpendicular to, oh sorry, this first vector is perpendicular to this second vector. Ayan. So for this example, we just want to figure out if these two vectors are orthogonal. So perpendicular means 90 degrees. Orthogonal, in other words, in the context of vectors. No? Although orthogonal could still mean a different kind of things depending on the context in mathematics. But for this case, for vectors, we know that orthogonal means perpendicular or 90 degrees. So how do we know that it is orthogonal? Their dot products should be equal to 0 if orthogonal. 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 Now, let's find the dot product of these two. So this will be equal to 2 times 5, and then plus 2 times negative 4, and then plus negative 1 times 2. So this will be 10, this will be negative 8, and then this will be negative 2. So this will be 10 minus 8 minus 2, so basically 0. So if this is 0, therefore, again, it is orthogonal or perpendicular. It is that simple, no? Okay, so that will be all for this video. See you guys again in the next video.